Hey ladies and gentlemen, you can see we got the review sheet for 737476 up. I'm going to rip through this pretty quick for you. Hopefully it'll be quick and painless. I'm going to do f and g of 1, so the first thing I want to do here is plug in for g of 1. I want to solve that, so I'm going to put 1 to 1/3 plus 2. I'm going to evaluate this. The cube root of 1 is 1, so 1 plus 2 is 3. So really I'm testing out f of 3. So f of 3 we're going to put into this guy. So we're going to have negative 5 times 3. So f of g of 1 looks like we're going to get negative 15. Okay. Number 2 is a composition where we're plugging in h of x into the function of g of x. So h of x is 4 plus x squared. At this point I'm going to rewrite my g of x. Except instead of this x here, I'm going to put parentheses. So I'm going to go x to the 1/3 plus 2. Then I'm going to plug this guy in, 4 plus x squared, for my h of x. If I try to take the cube root of that, there's nothing I can really do here. Okay? I can write it as a cube root. I could write it like this. But I'm really not going to be able to do anything from this part. That's where I would want to stop. Number 3, this can be written as g of x plus h of x. Distribute the x in, because when you look at it this way, it's kind of confusing. However, if you look at this equation, or expression I should say, that looks a lot more user-friendly. So we're going to do g of x, which is x to the 1/3 plus 2, plus h of x, which is 4 plus x squared. Any like terms? Absolutely not, except for the constant terms there. So I got x squared plus x to the 1/3 plus 6. That's where you would want to stop. Let me shift the screen around a little bit here, and I'll be right back. All right, continuing down the bottom with number 4. Remember, this is f of x minus g of x. We distribute the x in. Makes your life a little more easier. So I got negative 5x going into the f of x minus g of x to be x to the 1/3 plus 2. Distribute this negative in, so I'm going to get negative 5x minus x to the 3rd minus 2. Okay. That's really all you can do there. These are not like terms. X to the 1st is different than x to the 1/3. So, if we look at f times h to the negative 2, we can also think of this as f to the negative 2 times h to the negative 2. So let's evaluate f of negative 2, shall we? Which would be negative 5 times negative 2. F of negative 2, we can think of that as positive 10. H of negative 2 will be equal to 4 plus negative 2 squared. So h of negative 2 will equal 4 plus 4, which is going to be 8. So if we end up multiplying these, this would be 8 times 10. So we're looking at 80. So this is equal to 80. Number 6. We're going to do h of 8 divided by g of 8. So let's first evaluate what h of 8 would be. H of 8 would be 4 plus 8 squared, which would be 4 plus 64, which we know is 68. So right now I have 68 divided by something. Well, let's test g of 8. G of 8 would be 8 to the 1/3 plus 2. The cube root of 8 is 2. 2 plus 2 is 4. So really I'm doing 68 divided by 4. 4 goes into 6 once with the remainder of 2. 4 goes into 28 and 7. So 17 is your final answer for number 6. Okay, I'm going to go ahead and pause this. Shifting down to part 2, we're talking about find the domain of the following. Remember, domain is what all the values of x that will work. So if we're looking at number 1 here, the only thing we can't have in this denominator is a negative. Or should I say not a negative, but a 0. So all I have to do is set x minus 2 equal to 0, solve for that, x is 2. So this would be all reals, except x equals 2. If we're writing this in interval notation, we would go from negative infinity to 2, parenthesis, this is not included, and, sorry, I put that upside down, and from 2 to positive infinity. I think I was right the first time. Right. Jumping down here to number 2. We can't divide by 0, and we can't take the square root of a negative. So in all reality, the restriction for the denominator would be this has to be equal to or greater than, or should I say just greater than 0. It can't be small, it can't be equal to 0 because we can't divide by 0. So it has to be greater than 0. So that would be x is greater than negative 5. So again, we're looking at all reals, except x is less than or equal to negative 5. Or you could say all reals greater than negative 5. I would probably prefer writing it like that. As far as interval notation goes, okay, we want to start at negative 5, but it's not included and go up to positive infinity. That would be your interval notation for the domain. Negative 5 and part. Last but not least, there is no division here. There is no square roots. So you really don't have to worry. There's no restrictions on your domain here. So this is literally all real numbers. All reals will work. Again, interval notation will be negative infinity to positive infinity. There we go. Find the inverse function for part 3. Probably the easiest way to do this is to take the x and the y values, switch your x and y, and now we're going to solve for y. So if I do this, I'm going to subtract 7 over. I get x minus 7 equals negative 12y. And then I'm going to divide by negative 12. So my y is going to equal x minus 7 all over negative 12. There's my inverse function. Let's do g of x. Same idea. Let's put y in here for g of x. Let's switch the x and the y. Let x minus 6 equals half y. And then I'm going to multiply both sides by 2. There's your inverse, 2x minus 12. So think about your steps here. Okay. We're going to switch x and y. Step 2, solve for y. And that's how you would do your inverse. Since the last time I checked for my inverse by doing x and y, switching and solving for y, this time I'm going to do this a little different. Algebraically, I can do what I did in the last two. Or I can check to see if f of g of x equals x. That's 0, x. And I would have to check to make sure g of f of x equals x. These two things check out algebraically. I know that these are inverses. So what I'm going to do is I'm going to go ahead and do f of g of x. So that means I have f of negative half x plus 2. If I rewrite my f, which is negative 2x plus 4, I can put in my negative half x plus 2 in for that break. Distribute in this negative 2, and that's going to give me basically positive 2 over 2x plus 4 over, sorry, negative times positive is negative 4 plus 4. So this is x plus 0. So far, so good. So f of g of x equals x, absolutely. Let's switch it around and check to see if g of f of x does not equal x. Well, I'm going to go ahead and write g of negative 2x plus 4. I'm going to rewrite my g, which is negative half, parentheses plus 2. I'm going to plug this into here. So I have basically positive 2 over 2 of x minus 4 over 2 plus 2. That's 1x. This cancels out. That's 2 minus 2. So are these inverses? They are inverses because f of g of x equals x. And g of f of x equals x. So both scenarios checked out. Okay, check it for extraneous solutions after we solve the following. Please remember, your first order of business is to get the radical by itself. So that means this 10 has to go bye-bye, so I get x plus 56 equals 16. Subtract 10 from both sides. So, get rid of a radical or square root, use square. The left side is always the simplest, you can just rewrite it. 16 times 16 should be 256. I'm going to subtract 56, and I'm going to get 200 for my x value. So to check if this is an extraneous solution, all I have to do is plug this back in. So when you start talking about your check, I'm going to have 200 plus the square root of 56 plus 10 equals 27. So the square root of 256 plus 10 equals 26. Square root of 256 is 16. And yeah, you can see that this is going to work. So this is not extraneous. This is a good solution. Number 2. The square root, which is this, the square root is already by itself. So let's square both sides right to the get-go. So this is going to be 2x plus 5 equals 16. Subtract 5, I'm going to get 11, and then I'm going to divide by 2. So 11 halves is looking like my solution. I now want to go ahead and do my check by substituting that back in. Let's make sure it works. So I have 2 times 11 halves plus 5. And I'm going to take the square root of it and see if it equals 4. 2 divided by 2 is 1. 1 times 11 is 11. So 11 plus 5 to the 1/2 equals 4. This is the square root of 16. Yeah, square root of 16 is 4. So this one's a good answer. Checks out. Scooting down to 3 and 4 on your review sheet. Again, make sure the radical is by itself. This square root is totally by itself, so you could go ahead and square these both right away. This is x squared plus 5. I'm going to have to FOIL x plus 3 times x plus 3. So, again, the left side is already done. We're finished. We're really going to have to spend time FOILing this right side. So, what's kind of nice about this is the x squareds cancel out. I'm going to subtract 5 to this side. So I get 6x plus 4. well, I don't really have a factor here.